round-robin scheduling policies uses a preemption approach, which is based on clock, which means that for a single process, there will be a certain amount of time that the process is allowed to execute in a processor before it is interrupted by another process, and this another process is allowed to run. So basically, each process will get an equal amount of execution time before passing on the processor to the next ready process. So the time sharing concept is realized using a time slicing approach, where each time slice is quantified using Q. So Q or quantum could be Q equal to 1, or Q equal to 4, or Q equal to 8. So in this example, process A arrives at time 0, so process A will be admitted into the queue. So because no other process are available at that time, so process A is selected to be processed in the CPU. At time 1, again, no other process around, so process A is the only process in the queue, so process A is not preempted and can continue its operation or executed in the CPU. At time 2, B arrives. Because there is a new arrival, so process A is preempted, and now B is being run in the CPU. At time 3, there's only 2 processes in the queue, but A is at the front of the queue, B is preempted, so now A is selected to be run in the queue. Now, the service time for process A is 3, so process A has completed its service time, and process A now complete its execution. So since process A has completed its execution, so process A will be terminated and no longer be in the queue. So now the only process in the queue is process B. At time 4, process C arrives, and process B is selected to be run in the CPU because process B is at the front of the queue. At time 5, process B is preempted, and now process C is run in the queue. At time 6, we have process B, and then process D arrive, and then process C is preempted from the queue. So the process, if there is any, in the operating system, the process of selection which between the new arrival and the preempted process is arbitrary, but in our case, because we want to be consistent, so we will choose the new arrival process to be admitted earlier than the preempted process. So now process B is selected to be run in the CPU. Next, at time 7, process B is preempted, process D is at the front, followed by process C, and then the preempted process B. So D will be selected to be processed or run in the CPU. At time 8, process E arrives. So process C at the front, followed by process B, and then we admitted the new arrival, which is process E, and lastly the operating system will admit the preempted process, which is process D. And now what you can do is you keep repeating the process until all of the process has complete their service time. So I'll just repeating the process. So now B is at the front, ED, repeat the process until all of the process has reached their execution time, their service time. So now process E has complete the 2 time steps of service time, so process E complete. So we repeat with the remaining process. Oh, my mistake here. So process D, because process D is preempted, so process D will be at the back of the queue. So C. So now C, we have 1, 2, 3, 4. So which has reached its service time, so process C complete. And then we have the remaining B and D. The completed process, you could not include it in the queue anymore because the process has been terminated. So process B has reached its service time 1, 2, 3, 4, 5, 6. So process B complete. So now the only remaining process is process D. Okay, because we start from time 0. Okay, so the execution pattern here, it did the 20 here, the time 20 here is just to show the finish time of process D. Okay, so we can draw the execution pattern by looking at the column process in CPU. So we transfer all of the information on the determined process in the CPU in the execution table. So what we will get is, so we will get A is run at time 0 until time 2. So what you need to do is you just transfer the process execution in the last column in the to get the execution pattern. So from here you can get the finish time. So the finish time of B is at time 3. I'm about to say A. Sorry. So I erase this back. So A finish at time 4. B finish at time 18, C finish at time 17, D finish at time 20, while E finish at time 15. So that's all for the round robin. In the next video, I will compare the performance of the 4 scheduling algorithm that we have discussed so far.